Hello class. Today we're going to be reviewing over acceleration. So we've already covered speed and velocity, displacement and distance, and now we're looking at acceleration. So our definition of that is the rate of change, or how quickly an object, something, changes its velocity. It can be a change in speed or direction, and that's often the part that people forget when we're looking at accelerating objects. They can accelerate by maintaining a constant velocity but changing direction, or by staying in the same direction and changing their velocity, or having both things occur, so change in velocity and direction. An example, circular motion is a constant acceleration. The fan blades might be going the exact same velocity continuously as far as the speed, but their direction is changing, so therefore their acceleration is changing. So if we wanted to look at a graph or look at a table and then be able to develop a graph from this, we could look at acceleration in a constant situation, a constant acceleration. And this we would note by the change that is happening here between each interval. And here we can see that the change is a 4 each time. So our acceleration is going to be fairly constant. The change in speed is noted as a constant change in speed. It's the constant number every time. Or we could have a changing amount of velocity each time. And so in this one, we change by 1. Here it's by 3. Here it's by 1. And here it's by 2. So it's constantly changing, this individual speeding up, slowing down, and speeding up again. And so you can see that change in velocity as a little more sporadic. So if we have constant velocity, it would look kind of like this, and kind of a dot path with our car. We can see where it is each second in this image. In this one, there's zero acceleration because we're maintaining a constant velocity. So just staying at 10 meters per second will be no acceleration. Positive velocity equals positive acceleration. So in this one, the object started at rest and continued to increase its velocity. And so here we see constantly changing velocity, but it's a constant positive. We can see that diagonal line here. It's not that it's going up and then over and then down and up and over and down. It's just a straight, continuous diagonal line that allows us to see the acceleration. Calculating acceleration is going to be an equation here, final velocity minus initial velocity over time. Now if you'd like, you can do our triangle that we've been doing in class, and that would be represented by change in velocity on the top, acceleration here, and time here. So as we talked about in class, if you're looking for acceleration, you would cover up the A, and you would see what the other two things are doing, and they are dividing, so change in velocity over time. If you were looking for time, you would cover that up, and you would see that we have change in velocity over acceleration. And then if you're looking in the change in velocity, you would cover that up, and you would see the acceleration times time. So this helps you to rearrange the equation a little bit easier, possibly. So a couple things here. Final velocity, often people are like, well, which one's final and which one's initial? Final is wherever they were at the end of the problem. So if it says that an individual started at rest, that would be here, started at rest, initial velocity, which would be 0, and they ended at 50 meters per second. Then that would go here, so it would be 50 minus 0, and then however long it took them to do that. While you're doing this, you may note that sometimes you're going to end up with they came to a stop, so that would be 0 meters here, and that would be 0 meters per second, sorry, and this would be maybe 50 meters per second. If you notice, that will make it a negative number. That just means that you have slowed down or come to a stop. So that would be negative acceleration, which is a possible thing because they're decelerating or slowing down. This can be abbreviated VF minus VI over time. This being VF being final velocity, VI being initial velocity. Another way it can be written is triangle V over T. And this triangle here just means change in. If you end up being a student that goes into chemistry, you'll see that triangle quite a bit. You'll be working with that quite a bit. So our unit for acceleration is generally meters per second squared. You do have to add direction, but this right here might not always be meters per second squared. It might be kilometers per hour squared. It might be miles per hour squared, centimeters per minute squared. It can be quite a variety of things depending on what the problem gave you. So a practice problem. Natalie accelerates her skateboard along a straight path from 0 meters per second to 4 meters per second in 2.5 seconds. Find her average acceleration. So we need to take the information here and decide what everything is. Probably the easiest thing to determine is time. So 2.5 seconds is going to be equal to time. And then we need to see which one's final velocity and which one's initial velocity. So she's going along a straight path from 0. So that is her starting point, initial velocity, to 4 meters per second. So that means that's going to be her final velocity. So you'll see here, we have 4 minus 0 over 2.5. You would just divide that out and come to 1.6 meters per second squared along her path. So there's multiple things that are being counted here as points. A correct number is one point. Having your correct unit is another. And then this, having a direction, is part of the unit. On some problems it might be an extra point, or it may just be part of the unit. Usually I just do it as part of the unit. There are some more practice problems on page 328, numbers 2 through 5. This practice problem was number 1, so you could practice 2 through 5 and check your work in class if you would like. Here's an example of positive acceleration looking at this car. So we have acceleration is 30 minus 0. Final velocity was 30. Initial velocity was 0, started at rest, divided by the 10 seconds that they tell us in the picture. So that would be 3 meters per second squared in positive acceleration. If we looked at negative acceleration, this car is slowing down. So this is still final velocity here, but it's 0. And this is initial velocity of 20 meters per second. It still occurs in 10 seconds, so this car is coming to a stop. 0 minus 20 over 10 will give us negative 2 meters per second squared. You could write it that way, or you could write the car's acceleration is decreasing at 2 meters per second squared. That would be a fine way to say it as well. So it's still accelerating. We often think of accelerating as speeding up, but acceleration, that word, just means a change in velocity, so it can be slowing down as well. A lot of times you may think of the word deceleration instead, and that's fine as well. Okay, that's the end of our acceleration notes.